Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over a few example problems of how to solve limiting reagent problems. So let's get into this. So problem number one. So if you reacted 150 grams of potassium with 225 grams of bromine, how many grams of KBr, potassium bromide, can be made? And how much excess reagent is left over. So obviously this is a limiting reagent problem because they're asking you how much is left over. But you can also identify this as a limiting reagent problem because of the fact that they're giving you two different amounts of your two reactants. They're giving you 150 grams of potassium and 225 grams of bromine. So you can't assume that everything's going to react all together and 100%, right? So you got to figure out which one of those is the limiting reagent, if there is one. So first thing you want to do, first step is, since they give you grams of your two reactants, you got to convert those to moles so you can make a comparison. So that's the first step. So take 150 grams. So I have 150 grams of the potassium over 1. And I'm going to multiply that by its molar mass to convert from grams to moles. And so the molar mass, if you look on your periodic table for potassium, it's going to be 39.10 grams of potassium for every 1 mole. So 1 mole of potassium goes on top. So again, I put the grams for the molar mass on the bottom so I can cancel out the moles of potassium on top here. So grams of potassium cancel out. Now I have moles. And when I calculate that, I get 3.836 moles of potassium. And then I do the same thing for bromine. So I have 225 grams of Br2 over 1. And I'm going to use the molar mass of bromine. And if you look up bromine and the molar mass, the atomic mass of bromine, multiply that by 2, you get 159.8. So 159.8 grams of Br2 on the bottom. So it'll cancel out with grams here, and 1 mole of Br2 on top. So the grams cancel out, and I'm left with 1.40808 moles of the bromine. All right, so now that I have the moles, now I can go ahead and compare these two. And so the next step is to convert one of these amounts to the other and see if what you have, or if what you need is what you have. So then my next step is I'm going to take this many moles of potassium. Since they're giving you this many moles of potassium, I'm going to calculate how much bromine I need to react with this amount. And then I'm going to compare that to how much they gave me. So this is how much I have right now. I'm going to use this to convert to the amount of bromine I need based on this amount of potassium. So then my next step is to take 3.836 moles of the potassium, and I'm going to use the mole ratio in my balanced equation. So I know that uh, for for 2 moles of potassium, I need 1 mole of bromine. So since I have moles of potassium here, I'm going to put 2 moles of potassium on the bottom, and I'm going to put 1 mole of bromine on top, Br2. So moles of potassium cancel out, and I can calculate the amount of bromine I need. So that's going to come out to 1.9 0.18 moles of potassium. That's the amount I need. So what do I have? This is the amount I have. This is the amount they gave me. So in order to react, oops, this should be bromine, Br2. So this is the amount of bromine I need to react completely with this amount of potassium. So this is the amount I need, but look at the amount I have. The amount I have is less. So that means I don't have enough Br2. So my Br2 is going to run out before I react completely with the amount of potassium I have. So that means that this is the limiting reagent because I don't have enough of this to react completely with all of this. Okay, so now that I know that what the limiting reagent is, I can go ahead and answer the question. So the question is, how many grams of KBr can be made? So now this is the limiting reagent. So to calculate the amount of KBr, I'm going to start with this amount that they gave me, since this is what's gonna be used up first. So let's go ahead and do that. So then what I can do is I can then take 1.408 moles of the Br2 over 1, and I want to know how much KBr I can form. Well, now I can use a mole ratio between the bromine and the KBr. So since I have this many moles of bromine, I know that the mole ratio is 1 to 2, so 1 mole of Br2 to 2 moles of KBr. So I'm going to use that to convert to moles of KBr. So since I have moles of Br2 here, I'm going to put 1 mole of Br2 on the bottom. And I'm going to put the 2 moles of KBr on top. So 2 moles of KBr on top. So moles of the Br2 cancel out. And now I have moles of KBr. And so what are they asking me? How many grams? So I'm going to now need to use the molar mass of KBr. So I'm going to have to use that. So 1 mole of KBr is going to be used. So the molar mass of KBr is 119 grams. So let's see here. Okay, so it's going to be 119 grams of KBr. So 1 mole of KBr is equal to 119 grams. So I'm going to put 1 mole of KBr on the bottom and 119 grams of KBr on top. So moles of KBr cancel out. And now I'm left with grams, which is what they're asking for. They want to know how much in grams of KBr is made. So now all I do is I use my calculator, take the 1.408, multiply that by 2, multiply by 119, and it's all ones on the bottom, so you don't need to divide by 1. And so we get, for our final answer, is going to be 335.1 grams of KBr. So that is the amount of KBr that can be created from this mixture of potassium with bromine. The next question that they ask you is, well, how much excess reagent is left? Well, so we can do that by going back to the amount we have, right? So this is our excess. So this is the limiting. So that means this is our excess amount here. So, well, how much of this excess is going to be left over? Well, what we can do is we can take this amount. We know that this is going to be gone. So we can take this amount here and calculate. We already did that. We could calculate what the amount of potassium that's used up here, right? So here we went and got this. So now we can take this amount of bromine and calculate the amount of potassium that would be used and then subtract that from the amount given to us. So let's go ahead and do that. So let's find some space. We can do that up here. So here I'm going to take this. So I have 1.408 moles of Br2 over 1. I'm going to use the mole ratio to convert bromine to potassium. So the ratio is 2 to 1. So I have a mole here. So I'm going to put bromine. I have 1 mole of bromine. So 1 mole of Br2. And I'm going to put 2 moles of potassium. So 2 moles of potassium on top. So moles cancel out. And so now I can calculate that. And the number of moles of the bromine, the potassium is going to be 2.816 moles of potassium. So that is the amount that is needed. And then I can subtract this from the amount that's given. So I take the 3.836 moles, subtract out this, so 2.816 moles. And then what's left is going to be, let's see here, it's going to be 0.002 1 point, yes. So 1.020 moles of the potassium is going to be left, and we can then use the ratio, we can use our molar mass of potassium to convert that to grams to find out, well, how many grams are going to be left over. So you can then take this, and then so if we take 0.020 moles of potassium and then multiply that by the molar mass of potassium, which we have right here, 39.10 grams. So 1 mole of potassium on the bottom and 39.10 grams of potassium on top. So moles of potassium cancel out. And then if I calculate that, we would get give me a second here to calculate it. It would be 39.882. So 39.88 grams of potassium would be left over. So that's how you answer or solve a limiting reagent problem. So this is problem 1. Let's do problem 2. Okay, so here is problem number 2. So problem number 2 says if you reacted 13.2 grams of iron with 6.32 grams of oxygen, how many grams of iron oxide or iron 3 oxide can be made? And how many grams of excess are left? So we know that this is a limiting reagent problem because again, they give you two different amounts for each of these reactants. So they give you an amount of iron and they give you the amount of oxygen, and they want to know how much of the product is made. Well, you can't determine that unless you figure out which one of the reactants they give you is the limiting reagent. And so that's the first step. So again, the first step in this type of problem is to convert the grams. Since they gave us grams, we want to convert those to moles. So we're going to convert each of the amounts of reactant from grams to moles. So we'll start with the iron. They gave us 13.2 grams of iron. So I'll put that over 1. And we'll use the molar mass of iron to convert to moles. So the molar mass of iron is 55.85 grams per mole. So since I have grams of iron here, I want to put grams of iron on the bottom. So 55.85 grams of iron on the bottom and 1 mole of iron on top. So grams of iron cancels out, and then I get moles of iron. When I do the calculation, I get 0.236 moles of iron. And then I do the same thing with the amount of oxygen. So I take 6.32 grams of O2 over 1. And then I'm going to use the molar mass to convert grams of oxygen to grams to moles of oxygen. So I have grams of O2. O2 is going to be 32 grams. So I have 32.0 grams of O2 on the bottom, 1 mole of O2 on top. So grams cancels out. And when I calculate this out, I get 0.198 moles of O2. So that's the first step. So now that I have my two reactants in moles, now I can figure out, now I can compare the two and see if I have what I need. So then what I'm going to do is I'm going to take the amount of iron, and it doesn't matter which one you do, right? So I'm going to take iron and I'm going to use the amount of iron I'm given to calculate the amount of oxygen I need to react with this amount of iron. And then I'm going to compare with what I need to what I have. Now I could do that with oxygen too. I could convert this amount of oxygen to calculate the amount of iron I would need to react with the iron or react with the oxygen, and then compare that to what I have. But I'm going to just take the iron. So I'm going to take the 0.236 moles of iron, and I'm going to use the mole ratio in my balanced equation here to convert moles of iron to moles of oxygen. So since it's 4-3, 4 moles of iron needs 3 moles of oxygen to react completely. So I have moles of iron here. I'm going to put 4 moles of iron on the bottom. So I have 4 moles of iron. And then I'm going to put 3 moles of oxygen on top. 3 moles of O2. Moles of iron cancel out. And when I calculate that, I get 0.177 moles of O2. So this is the amount that I need, and this is the amount I have. So what I need is 0.177 moles of oxygen. What they gave me is 0.198. Now, I have more oxygen than I need. So I have an excess of oxygen. So that means that oxygen is the excess. So I'll use X is my excess, which means that iron has to be the limiting reagent. So the limiting reagent is iron. Now that I figured out what the limiting reagent is, I can now go ahead and calculate the number of grams of iron 3 oxide that can be made from this amount of iron. So let's go ahead and do that. So I'm going to take the amount of moles of iron, so 0.236 moles of iron, and I'm going to convert that to grams of my iron 3 oxide. So first thing I need to do is convert moles of iron to moles of Fe2O3. And so it's a 4:2 ratio. So what I'm going to do is I'm going to put 4 moles of iron on the bottom. And I'm going to put 2 moles of Fe2O3 on top. So 2 moles of Fe2O3 on top. So moles of iron cancel out. And now I have moles of iron. I'm going to use the molar mass. I have the moles of Fe2O3, iron 3 oxide. I'm going to use the molar mass of Fe2O3 to convert to grams. So the molar mass, here, let me get rid of this. So this is the amount I need. So need, and I'm going to use the molar mass. So the molar mass of iron 3 oxide is 159.69. So 159.69 grams of Fe2O3 goes on top. And since I have moles here, 1 mole of the Fe2O3 goes on the bottom. So moles cancels out, and I'm left with grams of Fe2O3. So now to calculate the grams, all I need to do now is multiply 0.236 times 2 times 159.69, and then divide by the bottom. Divide by 1, divide by 4, divide by 1. Of course, we don't need to multiply and divide by 1, but whenever you have anything on the bottom, you're going to divide by, not multiply. So when I do my calculation, I end up with 18.84 grams of the iron 3 oxide. So that's the number of grams that I'm able to produce from this amount of iron, which is the 13.2 grams. So the next question then is, well, how many grams of excess are left? So we said that the oxygen is my excess. So what I can do is then I can take this amount of iron and convert it to the amount of oxygen that I need, which I've already done, right? So this is the amount of oxygen that I need, right? And this is how much I have. So to get the excess, all I need to do is subtract the amount I need from the amount I have. So I go 0.198 moles of O2 minus, that's what I have, minus what I need, 0.177 moles of oxygen. And when I subtract that, I get 0.0 moles of O2 left over. Yeah. And so now what I can do is I can convert that to grams to get the grams that I would have left over. So then I have 0 0.021 moles of O2 left over. And then I can use the molar mass to convert that to grams. And so we know that 1 mole of O2 is equal to 32 grams of O2. Moles of O2 cancels out. And then all I need to do is multiply 0.021 times 32. And when I calculate that out, I get, as a final answer, I'll write it over here, 0.672 grams of O2. So that's the amount of O2 that's left over. So that is problem number 2. And so that's all I have for this video. So if you enjoyed this video, if this was helpful in any way to clarify how to attack these limiting reagent problems, then please make sure you like this video, hit that like button, smash that like button, share my video with others. Also, make sure you subscribe to my channel and hit that notification bell so you can be notified by other videos I put out. Put a comment down in the comment section. Let me know what you think and if you got any questions for me. I'd love to hear from you. Thanks for joining me and have a great day.